In this video, we're going to demonstrate using the static water column pressure function of the PPI BCD plastic pipe design calculator. This is the newest function to the calculator that was added in December 2022. From the calculator homepage, I'm going to review my end user license agreement and then click on Agree. Now I can click on the blue button in the left margin for the static water column pressure function. The first thing we notice at the top, under the input bar, is that there are two different column types available: geothermal or mechanical systems, which includes plumbing, fire protection, and hydronic. For the first example, we're going to do a geothermal project, as indicated by the graphic that is shown here. So in this graphic, what we're looking at is a completed vertical geothermal ground loop piping system. We've got two horizontal supply and return headers at the top, and then we have a vertical pipe that goes down into a deep borehole, cored in the ground, and then returns back up to the other header at the top. What we want to calculate is what is the static water column pressure at the point of maximum pressure at the very bottom of that vertical U-bend assembly, at the bottom of the borehole. To do this calculation, we scroll down a little bit. The first thing we do is we enter our pipe or tubing material. In this case, it's going to be high-density polyethylene, PE4710, which is most typical for this application. This pipe is going to be an iron pipe size, or IPS pipe, with a wall thickness or dimension ratio of SDR11. And the diameter I'm going to use is 1-inch diameter pipe, which is typical for a vertical borehole situation such as this one. If I wanted to get more information about HDPE pipe for geothermal systems, I can click on the blue link below the image of the pipe, and that'll take me to the BCD webpage all about HDPE geothermal pipe. To enter my job information, the first thing I need to enter is the P surface, or pressure at the surface, which is defined in footnote number 3. It says surface pressure refers to any internal pressure applied to the fluid inside the piping at the top of the vertical pipe riser. If the pipe is open to the atmosphere at the top, then P surface equals 0, and that's very unlikely in any kind of system here that you would have it completely open to the atmosphere. Even in our geothermal systems, the horizontal piping buried at the top of the boreholes, there's typically about 15 psi of pressure inside those pipes. So I'm going to enter that value in here. The depth of the borehole I'm going to enter as 400 feet, which is typical for a lot of vertical borehole installations these days. And for my fluid type, this system, as I've learned from the designer, is using 20% propylene glycol to protect it against freezing in very cold operation. My average fluid temperature for a vertical borehole, depending on where you are in the country and how the system is set up to run, is typically around 60 degrees Fahrenheit. That would be the midpoint between 30 degrees, a low temperature, and 90 degrees as a high temperature. So I'll use that as my average fluid temperature. So that's all I have to do for my inputs. Now I scroll down a little bit and hit the blue Calculate button. And that shows me my result, which is that this borehole, this U-bend, will have a static water column pressure at the bottom of the vertical column, or the bottom of the U-bend, of 192.1 psi. Now, based on the pipe that I selected up above, which is SDR11 PE4710 pipe material, that pipe is actually rated for 200 psi working pressure, or continuous use pressure, at 73 degrees Fahrenheit. So in this case, this system will be okay because 192 is less than 200. So that gives me the result I needed to know. Now let's do another quick example. We'll scroll back up to the top and do a plumbing, fire protection, or hydronic example by clicking the second radio button. And now I have a graphic of a mid-rise building. This building looks like it's about 8 stories high, and it looks like we have plastic pipes in red and blue color in this case as our vertical pipe risers, delivering hot and cold water to all the floors of the building. They're not necessarily red and blue, that doesn't matter, but that's just to kind of illustrate the graphic. So to calculate the static water column pressure at the bottom of that column of water, which would be in the mechanical room on the ground floor of the building, let's go down and use the same process. In this case, let's say my pipe material is polypropylene of the type PPRCT with a fiber core layer. That pipe is being produced according to ASTM F2389 with metric dimensions. My wall thickness or dimension ratio is going to be a dimension ratio of 9. And because of the size of the building, I'm probably going to need a 63 millimeter pipe as my vertical pipe riser to deliver all the fluid needed for all the floors. By the way, if I needed to get more information about PPRCT pipe, I could click this blue link, hyperlink below the graphic, and that would take me there. Now, the fields down below were already filled in based on the example I did previously, so I'm going to reset these. And the most important change is probably the pressure surface, because a plumbing system needs to have a certain amount of pressure in it, even at the very top floor, for customer satisfaction and for fixtures to operate correctly. So in this case, the plumbing design says that there's going to be 50 psi of pressure at the top of the building. This building, according to the drawing, looks like it's about an 8-story building, so let's type in that the height of the water fluid column would be 80 feet. And of course, it's hot and cold water plumbing, so it's going to be 100% water with no antifreeze. My fluid temperature right now is showing at 60 degrees from my previous example, and that's probably pretty accurate for the cold water plumbing system as an average fluid temperature throughout the year. So with those inputs, I'm going to scroll down again and click my calculate button. And the result this time is that the static water column pressure at the bottom of the vertical pipe column is 84.6 psi. Let's scroll back up here. Based on the fact that I used DR9 PPRCT pipe, that pipe is pressure rated for at least 100 psi at 180 degrees Fahrenheit. So that pipe easily has the capacity to withstand this static water column pressure. And that pressure is going to be constant at the bottom of the water column. It's not an on and off pressure, it's always going to be there. To view the calculation details, to determine how this was calculated, we can click this button in the lower left, and that opens a window that shows us the calculation details in both System International units at the top and inch-pound units at the bottom. So that's the math. Now to share these results with somebody or yourself, you have a few different options. You can click the print button, and that'll open up your printer driver. We could print this to a paper printer and then to go hand it to somebody. Your print driver probably also allows you to make PDF files, and then you could email that to somebody, and that would show all your inputs and assumptions and the results. Your other choice is to click the email button and to actually email the results to somebody. Just type in their email address and hit the send button, and the email will be sent directly. That concludes the instruction video on how to use the static water column pressure function of the PPI BCD plastic pipe design calculator. And thank you very much for watching this video.